The second objective of the lesson was classical curves or special type of polar graphs. We had gone through in the first video of introduction. So if you have not gone through the first video of this lesson, that is the introduction video, please go back and go through the special type of polar graphs. So I'll just quickly recall. Now you will be given the equation, and then you need to recognize the standard form and then graph tell which type of graph it is. Say for example, circles, the standard form can be either a cos theta, a sine theta. If it is sine, it will be either up or down depending on the a value. If a is greater than 0, it's up, less than 0 is down. For cos, if a is greater than 0, it's right, less than 0 is left. Same way, Limassons. So Limassol is basically okay. It's pronounced as Limassol or Limasson. So the C over here is as S. This is a C with a dash. So now over here there are four types of graphs, but one is also cardioid. Cardioid. We have done problems based on this. Whenever the A and B values are same, it can be the it should be plus. A and B value must be same. So now it can be the cos or sine. It can be plus or minus. Now it depends on the equation. Based on the equation, you must know whether it is the inner loop Lamassan or dimpled Lamassan or convex Lamassan. So it depends on the given equation. So you must be thorough with this equation and the type of graph. There are roses, it depends on the n value. We have gone through all this in the introductory video. And then there is, sorry, lemniscates. There are only two types. Either it is in this form, a cos or sine form. If it is cos, it is symmetrical along the axis, the center, sorry. Over here it's like this, left side and right side it's the same. But whereas over here, it is from the polar axis, it is symmetrical. And this is the spiral of Archimedes, the last one. Let us solve some problems over here. Now here we have been given a standard form, that is r squared equals 16 sine 2 theta. We need to identify the curve. We need to tell the symmetry, zeros, maximum value, and r value, and also graph this. Looking at this, you will know if it's r squared, only lemniscate has it. So see, this is a lemniscate because it's r squared. Standard form is sine is this, so it's a squared sine 2 theta. We just now saw it over here. See, this is the one. Now over here, it is symmetrical with respect to the pole. See over here, this is the pole. So it's symmetrical over here. And then this is lemniscate. And then what else can you know? This is the standard form. It's always like this, but this is not the graph for this one, because when we have values over here, when we make the table of values and graph, the graph will be different. Now what about the zeros? See, this is a sine function. Okay, so now the domain is restricted. See, look at this over here. If it was cos, then it would have been over here and over here. Okay, but this is sine. It's slanted. The domain is restricted to where and where? From 0 to pi by 2 and from pi to 3 pi by 2. This is very important whenever it is sine. Okay, so it's from 0 to pi by 2. This is the possible domain, and pi to 3 pi by 2. And where does it have zeros? It has 0 at x is 0 and pi by 2. So these are few things. And then what else do we have? The maximum value. Now maximum value, it depends. Now we will see over here, when we graph, we will get the answers generally. See, the maximum value, where is it happening? It is at pi by 4. Okay, so the maximum value, our maximum value, is at pi by 4. So when we make the table of values, you'll come to know. And where are the zeros? At 0 and pi by 2. Okay, so now these are this is just the basic understanding. The main thing is to make the table of values. So make the table of values from 0 to pi by 2. It's enough. Don't go to do both, because it's symmetrical, isn't it? So just do from 0 to pi by 2. That's more than enough. Now you'll get the answer, you'll get the values, you can plot, see, plot these points, few of the points, and you'll get the answer. And then you can extend it over here as well. Okay, so this is how we can easily graph it, and that's it. This is the answer. But now the most important thing is understanding which is the standard form and which is the given graph. That is very important. Similarly, you can try this, but these are all different. Now it is better you try to solve all the different type of classical curves. Now in this video I'll just do a couple of problems. Now the first one was on lemniscate. Now we will do this, the standard form of spiral of Archimedes. Now here there are two conditions for spiral of Archimedes. Now looking at this equation, you can easily tell it's spiral of Archimedes. These are this is the standard form, r a theta plus b. Now the zeros and the maximum value. Now look over here. Does it have a maximum value? No. These just keep on going, isn't it? So there is no maximum value. You can't bind this, it just keeps on going till infinity, so this has no maximum value. This is very important. But the zero is there at pi by 2. Now how we can do is substitute over here, make the table of values, you'll come to know. That's over here, we'll make the table of values. Now over here, since it is a spiral, we can't bind it. There is no domain restriction or anything. Look at this, it just keeps on going. So until how much will you do? Is it up till 2 pi? No, you can do until 4 pi. You'll get a better understanding. That is why we it's not symmetrical, so that's why we take some values of intervals from 0 to 4 pi. Even you can do 0 to 2 pi, but it's better you do more values. You'll get a better understanding. So you can take any interval and just make this graph. See, now initially you're taking more points over here, but as you go further, as you go more than 2 pi, just take 3 pi and 4 pi, because it'll be spaced like this. The spiral keeps on going like this. So now you have the table of values, plot the points and just graph it. That's it. This is the answer. So it's very simple and straightforward. If you're getting all confused with these directly, if you can't remember, okay, which is the standard form or anything, there is a simple way. Don't worry. What you can do is just make table of values and graph. Sorry, over here, make table of values and graph. Then you will get a figure, right? Then you will understand which type of classical curve it is. In this case, it is the spiral of Archimedes. And then you can say which is the zero, which is the maximum value. This does not have maximum value because it keeps on going. So you can find the basic details of it. So this is how we can do it. For any equation, just graph it directly, and then you can find the shape, and then you can tell about the graph. So this is it. So that is the end of this lesson. I hope you understood this lesson. If you have any doubts, please go back to the previous videos, watch the videos in continuity. But if you have any doubts, please write it in the comment section. I will try to get back to you as soon as possible.